Imagine that Kate is the Earth and people around her represent space debris. As demonstrated, the debris essentially forms a ring of chaotic and destructive metal chunks. Traveling at about 28,000 kilometers per hour, it poses a threat to intact artificial satellites and rockets entering Earth's orbit. This is especially critical when it comes to crewed satellites such as the International Space Station. The damage that even a small piece of debris can cause is pretty substantial. If the ISS gets hit, someone has to go and repair the damage. As of right now, it is estimated that more than 500,000 pieces of space debris orbits Earth. Every single piece originates from portions of spacecraft such as rocket stages or satellites. Considering the dangers of space debris and the price of rockets and space equipment in general, why not reuse the things we send to space? This is what SpaceX had in mind with their Falcon 9 rocket. Reusing parts of rockets would reduce the overall cost of launching them in the long run and prevent littering in space. Before we get to the usability of the Falcon 9 though, let's go over the rocket's capabilities.
Falcon 9 is a medium to heavy lift rocket designed to allow the transportation of satellites and cargo into orbit. The rocket is a crucial development for humankind since it is the first reusable rocket to be in service. It is only composed of 2 stages, thus minimizing separation events and making launches simpler. The first stage is composed of 9 Merlin engines and is responsible for bringing the rocket off the ground and into the sky. During takeoff, its 9 engines generate about 7,600 kilonewtons of thrust, making it possible for the rocket to lift up to 18.5 tons of payload into low Earth orbit. In addition, if the stage is expanded, 22.8 tons can be lifted. So, how heavy is that? To put it into scale, the amount equates to about 3 to 4 African elephants, or 47,500 to 58,500 pop cans. The second stage is responsible for getting the payload into orbit. Although it's substantially smaller than the first stage and has only 1 Merlin engine, getting the payload into proper orbit is crucial as well. Falcon 9 has 2 types of payloads, Dragon and composite fairing. Dragon is a spacecraft that is designed to carry people, materials, and equipment into orbit, and can house up to 6,000 kilograms of equipment and materials. When people are not being sent, payload fairing is used. Its main job is to protect the payload and is typically used for launching satellites into space. Prominent for its reusability, the Falcon 9 is the first orbital-class rocket capable of reflight. Even though only the first stage of the rocket is reusable, it makes up the majority of the rocket's size and 60% of the rocket's launch cost. After separating from the second stage, the first stage booster re-enters Earth's atmosphere and descends. Using its engines and landing legs, it can land vertically either on land or drone ship. Being able to reuse the rocket creates less space debris and significantly reduces the cost of launching rockets, both in terms of resources and finance. This makes accessing space much easier and cheaper, which is required for human advancement in space. Currently, Falcon 9 and Falcon Heavy, which is essentially Falcon 9's precursor, are the only operational reusable rockets in the world.
Despite the many positive features of the Falcon 9, it has one drawback. Due to its type of design, fuel, and payload, the rocket literally produces tons of emissions. With the reusability of Falcon rockets and the growing number of space launches per year, the potential for space advancement is higher than ever before. There is now a possibility of colonizing other planets and building more advanced satellite structures. If used with caution to minimize harm done to Earth's environments, the technology has the ability to push the human race forward into new territory.